Hi class, this is section 8.1, sequences and summation notation. So the first problem is asking us to find the first four terms and the 100th term of the sequence, and they give you the general term. So all we got to do is simply substitute 1 in for n, then you substitute 2, 3, 4, and then 100. So let's start with 1. A sub 1 is going to be negative 1 to the 1 over 1 squared, which is negative 1 over 1, which is negative 1. Substitute 2, you should get negative 1 squared over 2 squared, which is 1/4. Substitute 3 in for n, you get negative 1 to the 3rd, 3 squared, which is negative 1/9. Substitute 4, negative 1 to the 4th over 4 squared is going to be 1/16. As you can see, the signs are alternating. They're going negative, positive, negative, positive. All right, the last one is 100. So substitute 100, negative 1 to the 100th power over 100 squared. It's going to be positive 1 over, it's going to be 100 times 100. That's going to be 4 zeros, 1, 2, 3, 4, which is 10,000. So 1 over 10,000. All right, so that's number 1. All right, let's move on to the next problem. This is the same thing, but this time the function is defined recursively. That means you need the previous term to find the next term. So as you can see, they do give us the first term. They need to give you the first term, which is 3. Now we can use that to find the next term. So now, since we're looking for a sub 2, that means n is 2. So if you plug in 2 for n into this recursive formula, you're going to get 2a sub 2 minus 1, 2 minus 1, which is 1, plus 2. All right, and because we already know what the previous term is, we can substitute that in for a sub 1, it's 3, so I'm going to go ahead and erase that and just plug in 3. And then that's going to be 2 times 5, which is 10. All right, so for the next one, n is equal to 3 for the a sub 3. So we're going to do the same thing. A sub 3 is equal to 2 times, this time we're going to plug in 3 for n, so 3 take away 1 is 2. Plus 2. All right, and then we already know what a sub 2 is. We just found out in the previous step it is 10. So I'm going to erase this and plug in a 10 there. Plug it in red. I'll plug that one in red as well. All right, and so now if we evaluate that, it's going to be 2 times 12, which is 24. And so on and so on. For the next one, it's 4 for n. A sub 4 is equal to 2 times a sub 3 plus 2. And a sub 3, we can grab it from the previous step. That is going to be 24. So erase, plug in, substitute 24. And now we have 2 times 26, which is 52. All right, 52 it is. And the last one, n is equal to 5. A sub 5, 2 times a sub 4 plus 2. Substitute a sub 4, 52 for a sub 4. That will give us 2 times 54, which is 108. That does it for that problem. The next one is asking us to find the nth term of a sequence whose first several terms are given. So let's see what we observe or notice about this sequence. It looks like it's increasing by 3 each time. Plus 3, plus 3, plus 3. That means it's an arithmetic sequence because it has a common difference. The common difference is denoted by d, and it's positive 3. All right. The first term, notice, is a sub 1, which is also 3. And the formula for an arithmetic sequence, for the general term of an arithmetic sequence, is given by this formula. So the general term is equal to the first term plus n minus 1 times the common difference. So all we have to do is substitute these two values in for d and a sub 1, and that will give us an nth term. So a sub 1 is 3, n is our variable, d is equal to 3 as well. And now we can distribute and combine like terms. A sub n should be 3 plus 3n minus 3. Notice that these 3's are going to cancel, so the nth term is simply 3n. And we can check it to make sure it works. So if you plug in 1, which is the first term, you get 3. Check. If you plug in 2, which is the second term, you get 6. Check. If you plug in 3, which is the third term, you get 9, and so on and so on. All right, the nth term. So this is pretty much the same type of thing. The only difference is, notice that the denominator is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the denominator will always be n squared, whatever term you're on. If you're on the first term, it'll be 1 squared. If you're on the second term, it'll be 2 squared, which will be 4. If you're on the third term, it'll be 9, so on and so on. So now we have to focus our attention on the numerators. Notice that that is increasing by 2 each time. So therefore, the common difference is 2, which makes the numerator an arithmetic sequence. Oops, arithmetic. Arithmetic sequence. So we're just focusing on the numerator now. Since we already know what the denominator looks like, it's just n squared. Okay, so for that, we're going to do the same formula as we did in the previous problem, because once you've established it's arithmetic, which means it has a common difference, then that means you're allowed to apply the formula. So a sub 1 is 1. N is our variable, and d is 2. Once again, we distribute, combine like terms. So the nth term will be 1 plus 2n minus 2. Once you combine like terms, you should get 2n minus 1. So that is our numerator. So that is our final answer, actually, 2n minus 1 over n squared. And it's always a good idea to test your answer. So if you plug in 1, which is the first term, you're going to get 2 minus 1, which is 1, over 1 squared is 1. If you plug in 2, which is the second term, you're going to get 4 minus 1 is 3, check, over 2 squared is 4, check. If you plug in 3, which is the third term, you're going to get 6 minus 1 is 5, check, and 3 squared is 9, check. Let's do the last one, 1, 2, 3, 4, 5. The fifth term, if you plug in 5 for n, you're going to get 10 minus 1, which is 9, check. 5 squared is 25, and so it works. And the next problem, this is summation notation. It's a capital sigma. So what we need to do is start with the bottom, substitute 1 in for k, and we just keep on increasing until we get to the top number, which is 5. So the first term will be 2 to the 1 minus 1. The sigma means that you're adding. If you plug in 2 now, you're going to get 2 squared minus 1. Plus, now if you plug in 3, that's going to be 2 cubed minus 1. So on and so on. Plug in 4, and finally plug in 5. And that's where we stop, because that top number tells you where to stop. Oh, I forgot to subtract 1 over here, sorry. So 2 to the 1 minus 1. Whoops, I did the first one correct, and I did the rest of them wrong. Sorry. 2 to the 1 minus 1. This one should have been minus 1 in the exponent. As you can see, this minus 1 is in the exponent. It's not down below like what I have here. So let's fix that. Minus 1, fix that, minus 1. That's what I meant to do. All right, so now we can evaluate. 2 to the 0 is just 1. This is going to be 2 to the 1, which is 2. It's going to be 2 to the 2, which is 4. That's going to be 2 to the 3, which is 8. And that's going to be 2 to the 4, which is 16. So all we've got to do is combine these together. And if we do, let's see, that's going to be 20 and 10. So that's 20, that's 10, and clearly that's 1. So it's going to be 31. All right, next one they want us to use a graphing calculator, but we don't need to do that. Not everybody has one, so we can just do this by hand. Same exact thing. Plug in 5 and end at 17. So if you start with 5, you're going to get 5 squared, 1 plus 5. The next one will be 6 squared, 1 plus 6, so on and so on. So this will be a little tedious, but it's not hard. It's just tedious work. I have to wrap around over here because I'm going to run out of space. And continue down here. As you can see, this is a lot of tedious work. So I'm going to have you guys go ahead and type this into your calculators and do this on your own. So let's see. That's going to be 25 times 6. The next one's going to be 36 times 7. The next one will be 49 times 8. 64 times 9. 81 times 10. 100 times 11. I'm going to start down below. 121 times 12. 144 times 13. What is that going to be? That's going to be 169 times 14. So 169 times 14. And then 14 squared is 196 times 15. And that would be, what is that? 15 squared is 225 times 16. And then 16 squared is 256 times 17. And finally, 17 squared is 289 times 18. So whatever you get when you enter this into your calculators, that is your final answer. So I'm not even going to do it. It's just time consuming, but you guys can type this into your calculators and that will give you your final answer there. And I believe that concludes this section. Nope, there's one more. So here's the last problem. They want us to write the sum without using sigma notation. So we just plug in the values. The first one will be square root of 0 plus 3. The next one will be 1 plus 3, 2 plus 3, 3 plus 3, 4 plus 3, 5 plus 3, and finally 6 plus 3. That's where it ends because that's where the top number tells us that's where the top number ends. So we can simplify this a bit. Square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, and that will do it. There should be 7 terms. 1, 2, 3, 4, 5, 6, 7. Yeah. I mean, I'm sure you can simplify that to 2 and that to 3. But, I mean, I think if you enter your answer like that, that should do it as well. And that concludes this section.